Welcome back, students. In this video we're going to cover Module 9 topics 1 and 2. This is Pythagorean Theorem and special right triangles. This is, of course, page 1 of the Module 9 packet. Let's see. Scooch up here. I'm going to cover the objective. You guys are going to solve problems using the Pythagorean Theorem and its converse. And you guys are going to solve problems by using the properties of 45, 45, 90 and 30, 60, 90 triangles. And we will talk about that as we go. Alright, so the bell work number 1. Solve for the missing side. So, talking about Pythagorean Theorem, right triangles. All 3 of these are right triangles. So we're going to go a squared plus b squared equals c squared. C squared is the c is always going to be the hypotenuse. It's always across from the 90-degree angle. Just want to mention that up front. I say it all the time. So this one here is x. Looks like x is going to be the hypotenuse for number 1 and 2. Number 3, it's going to be one of the other sides, but. So, start with 12 as our a squared, 35 will be our b squared, and x is going to be our c, and x squared is going to be our c squared. Alright, so 12 squared is 144, and 35 squared, it is 1225. Still got x squared over there. We add these two together. It's going to give us 1369. Now we need to take the square root of both of these. And I'm just going to put up here x is, so if you use your calculator, the square root of 1369 is 37. So in this case, x equals 37. Alright, number 2. This will be our a, this will be our b. X, of course, is our c. Change colors. Alright, so 7 squared plus 9 squared is going to equal x squared. 7 squared is 49. 9 squared is 81. Is x squared. 49 and 81. I'm just going to move this up here, so x squared equals 49 and 81 equal 130. So we're going to take the square root of both of these. X is the square root of 130, which is also 11.4 approximately. Okay, number 3. This time x is our, I always like to make, a is the shortest, b is the middle. Either way, we're going to have, let's see, so x squared plus 3 squared equals 5 squared. 3 squared is 9, 5 squared is 25. So we're going to subtract 9 from both sides. I'm going to move it up here. X squared equals 16. Take the square root of both. X equals 4. Alright, number 4. Can a right triangle be made with side lengths 11, 12, and 13? Well, obviously 13 is the biggest number, so that's the c squared. And then the other two are your a squared plus b squared. So let's see. 11 squared is 121, 12 squared is 144, and 13 squared is 169. Well, this is not looking good. You add these two together, you're going to get 265, which does not equal 169, so the answer is no. A squared plus b squared has to equal c squared for our right triangle. Okay. Scooch down the page here. We're going to do our guided notes. So a Pythagorean triple is a set of 3 non-zero whole numbers. I'm going to call them a, b, and c, such that a squared plus b squared equals c squared. Sounds familiar. The most common Pythagorean triples are shown below in the first row. These are in bold. The triples below them are found by multiplying each number in the triple by the same factor. Okay, so like this line here, if you multiply all these numbers by 2, so 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. Over here, do the same thing. 5 times 2 is 10, 12 times 2 is 24, 13 times 2 is 26, and so on and so forth. If you multiply 3 times 3, you get 9. 3 times 4 is 12. 3 times 5 is 15. So that's what they mean by multiplying each triple by the same factor. So times 2, and then times 3, and then here they're just showing 3x. So 3 times that you could make, as long as it's the same number. 3 times 10, 4 times 10, 5 times 10, and so on and so forth. Alright, so the question here, it says, what if the square of one side of the triangle is not equal to the sum of the squares of the other two sides? So what if your c squared is not equal to your a squared plus b squared? Well, that's what we answer here below. So if the sum is greater than the third side, so if your a squared and b squared are greater than c squared, you're going to have an acute triangle. So notice these guys are longer, so this is shorter, making this angle acute. And then the other side, so if the sum is less than the third side, so if your a squared plus b squared is less than c squared, you're going to have an obtuse triangle. So here you see c is much longer than a and b, so it makes that angle an obtuse angle. Okay. Let's reposition here. Oh, sideways, sorry. Let's scooch down a little more. Okay. Alright, at the bottom, number 1. Classify the following triangle. So this is your c squared, it's your long side. Over here, that would be the c squared. A squared, it's a, b, and c, but anyway. So we're going to say 20 squared plus 19 squared. This looks like it's 28. It's hard to read that, at least for me. So it's over here, 28 squared. I'm going to make the line in between. I'm just going to draw another one down here because we don't know if they're equal, less than, or greater than. They're wanting us to classify, and we're going to use what we learned above to classify. So 20 squared is 400, and 19 squared is 361. Add those together and you got 761. 28 squared, 784. 784 is greater than this, so our a squared plus b squared is less than, a squared plus b squared is less than c squared, so we have an obtuse. Okay, just going to go ahead and do the same over here. Draw the line in the middle because we don't know. So a squared, b squared, we got 8 squared plus 24 squared is going to be something to 25 squared. Alright, so 8 squared is 64, 24 squared is 576. Add those together and we get 640. 25 squared is 625. So in this case, a and b are greater than c, so it's acute. Okay. Alright, let's flip over. Page 2. Talk about these special right triangles. Okay, so on the left we have the 45, 45, 90, and on the right we have the 30, 60, 90. So let's talk about 45, 45, 90. So going back to previous lessons, we learned that if our these two angles, and of course the triangle was flipped where those were at the base, but this is still the same triangle. If these two angles are congruent, these two sides are congruent. So for a 45, 45, 90, the two sides that are not the hypotenuse, remember the hypotenuse is directly across from the box, the 90 degrees, these two are equal. So they're called x. And I know folks go nuts over math teachers always looking for their x, but no, for real. This just means that this number and this number are the same. This, so up here it says x times the square root of 2. So your hypotenuse is this number, whatever it is. If x is 5, this is 5 to the square root of 2. If x is 10, This is 10 times the square root of 2. And we can use the calculator and get our real number, not a radical. But we'll go according to how the book asks. Below it's going to ask in radical form, as you can see here for 3 and 4. And then below those, it's going to ask you to the nearest tenth, so you're going to use calculator to get rid of the radical. All right, so looking over here, 30, 60, 90. So on the side that's the 90 degree and the 60 degree, that's x. So just stay with me. X is whatever number, x5, whatever. This side over here, the 90 to the 30, is whatever this side is times the square root of 3. And the hypotenuse is 2 times that, this side here, the 90, 60 side. This is our shortest side, it's going to be x. This is a little bit longer because it's x times the square root of 3. The square root of 3 is like 1.7 something. And then the hypotenuse is twice the length of that small side. So let's put this into practice. Every time we get into this section, you guys get way nervous on these x's. They signify the numbers. Let's just bear with me. So actually, let me leave this in view while we do number 3 so we can see, because we've got a 45, 45, 90, so we're over here. Okay? Find the value of y and z. Keep your answer in radical form. So they want to know y is this side, z is the hypotenuse. All right. I'm going to put in red. So up here we know 45, 45, 90 that these two sides are x, they're equal. So if down here is 10, y equals 10. Easy peasy. Whatever this is when it's a 45, 45, 90. All right, z, that's our hypotenuse. Well, it's this number times the square root of 2. So that number times the square root of 2. Or x times the square root of 2. Make sense? I know. There's a y there. Never mind. All right, number 4. They want to find the values of p and q. So they're calling this p, this q. 45, 45, 90. These two sides are congruent. So because this is 27, p is 27. Q is whatever p was times the square root of 2. Or whatever this was, because those are equal, times the square root of 2. Okay, all right, I'm going to have to move the paper down, but I want to keep that there. Let me make sure you guys can see on the screen. Okay, so bottom here, number 5. So well, actually, no, that's still, these are both still 45, 45. So never mind. All right, so over here, the side is, they want x. Find the value of x. Keep your answer in radical form. Okay, so these two sides were x. This is x times the square root of 2. So if we're looking for this x, I know we're always chasing x's. So if 18 includes x, let me just do this on the side over here. Let me do this. So if I'm trying to get rid of this, if this was in an equation, we would divide both sides by that, right? To get x, okay? So if 18 was over here, if 18 is this number, and we just, that's how we got rid of this to find whatever x is. I hope that made sense. If this number is x to the square root, x times the square root of 2, to get what this is, we divide it by the square root of 2 to make it x. Let me just do it this way. It'll make me feel better. You guys don't have to write this, but so if x times the square root of 2 equals 18, we're going to divide both sides by the square root of 2 so that x equals the square root of 18. I hope that clears that up. Everybody has a hard time with the radicals, and I do too, to be honest, but we'll get there together. All right, number 6. It's a little bit easier. So if this is x to the square root of 2, we're looking for x equals 5. I hope this helps you see this better. Because if this number means that, and we're looking for that, we have to pull that out of it, or divide it. If this is the whole thing, and it means x times the square root of 2, this is 5 times the square root of 2, then 5 and x are the same thing. Sorry, you guys can't tell, but I'm on my soapbox. All right. Let's move down. Number 7. And I wanted to keep that up there, and that's okay. I'm going to write it. So now we have our 30, 60, 90. They want y and z, and they give us 7. Okay. So up above, you can't see it, but so our 30, 60, 90, down here at the bottom where the 90 and the 60 are, this is x. Over here, this side is x times the square root of 3. So whatever this is times the square root of 3 is what you get here. And then up here, the hypotenuse is 2 times x, or 2 times that short side. So now let's use this to find. So our short side was 7. Y is our medium side, which is x times the square root of 3, or this side times the square root of 3. And that's it. Oh, they want the nearest tenth. See? I knew that would happen. So, 7 times the square root of 3. And the square root of 3 is like 1.7. Yeah, and I didn't do that. All right, hold on. Give me 1 second. 7 times 3 square root equals minus 12.12. We're going to round down and call it 12.1. Okay? Now z, our hypotenuse, z is 2x. So it's 2x, which equals 14. Okay, over to number 8. So I'm going to write in red the same rules we have here. So our short side is x, the medium side is x times square root of 3, and our hypotenuse is 2x. All right, so we have this side is 12, so q is going to be the short side, 12 times the square root of 3. And then if we take 12 times 3 square root on our calculator, we get 20.78, and we round that to 20.8. So Q is 20.8. All right, for P, that's the hypotenuse. That is 2 times the small side, which was 12, or x. 2 times 12 is 24. We don't have to round that one. All right, let me scooch down here, bottom of the page. All right, on the left, number 9. Find the values of J and K. So J is there and K is there. You'll have to trust me, these it didn't print well. All right, so our hypotenuse is 100, and I'll write this in red. It'll make it. So that's your 2x, because this is 30, 60, 90. J is your x, and K is x times square root of 3. So for J, it's going to be half of the hypotenuse. So the hypotenuse is 100. We're going to take half because the hypotenuse is 2x, J is x. So we need half of that. And half of 100 is, of course, 50. So that's easy enough. Now K is the medium side, so it's J being 50, times the square root of 3. And 50 times 3 square root equals 86.6. So your short side is 50, your medium side is 86.6, and your long side is 100. And that goes back to the, does my answer make sense? And yes, it does, at least in this case. Okay, another 30, 60, 90 right here. This is 60, I know that because that's 30. This side is your short side, that's x. This is your x times the square root of 3 side, and your hypotenuse, or n, is 2x. So they want n here, they have m here, and they want both of those rounding to the nearest tenth. So the only one we have a number for is this guy, and it's x is square root of 3. Well, remember, if we want to get x by itself, you have to divide the square root of 3. So x, or m in this case, is going to equal the medium side divided by square root of 3. And when you take your calculator and you say 3.46 divided by 3 square root, it equals 1.997. We're going to go ahead and round it to 2 because when we find 2x here, it's twice this, and we'd end up rounding again. So just trust me. So n is 2x. We found x, so we can just say n is 4. Or, let's see, it's 2 times x, or 2 times n, 2 times 2, which is 4. Okay, 1 second. Flip over page 3. This is the last of this these two combined topics. Okay, page 3. Sorry, I had a visitor. Okay. The perimeter of a square is 12. What is the length of the diagonal? All right, so before this first thing we need to do, let's draw a square. Maybe you draw better than me, and I'm going to draw one of its diagonals. Okay. Well, the thing about a square, we know it has 4 90-degree angles. And if these are 90, the diagonal cuts them in half. So you're really looking at a 45, 45, 90 triangle. Now, if the perimeter is 12, the perimeter is 16, and we know that each side of a square is congruent, right? So 16 divided by 4, that means each of these sides is 4. So that means that, so if this is a 45, 45, 90 triangle, because it's a half of a square, and we talked about this when we covered squares. So this is x, and this is x times the square root of 2. So your diagonal is going to be 4 times the square root of 2. You can also, if you want to do the math, because the square root of 2 is like 1.41, I think. So it's either that or it's 5.65 or 5.7. All right, number 12. Excuse me. Perimeter of an equilateral triangle is 36. So equilateral triangle, this is 60. 60, they're all 360. They're all 3 equal. 36 divided by 3 means that each side is 12. What's the length of the altitude? Well, the altitude's going to go up through the middle, and it's going to make 60. This was 60, and it cut it in half, so it's 30. And then the altitude, of course, makes a 90-degree angle. So we end up with a 30, 60, 90. In this case, the hypotenuse is 12. This was cut in half, so this is 6. They're wanting to know the altitude. Well, this is a 30, 60, 90, so this is x times the square root of 3, and this is 2x. Well, look, this is 12 and this is 6. It's half of it because it's a 30, 60, 90 triangle. So now, to get the diagonal, the altitude, it's going to equal x times the square root of 3. And if we want to do the math, 6 times 3 square root on the calculator equals 10.49. 10.39, which is rounded up to 10.4. Okay, scooching down, trying to hurry this up. I'm trying not to make the videos super long. Okay, find the missing side lengths on the figure. So up here, let's see. See, we have so if that's 45, we have a 45, 45, 90 triangle up here. That means these two sides are going to be equal, and this is going to be x times the square root of 2. We'll clean all this up. We've got a 30 here, we got a 90 here. That means we have 60 here. That puts this x, this. Now these may not be the same. This is just for this triangle. This is just for this triangle. This side over here is x times the square root of 3, and the hypotenuse here is 2x. Over here we have a rectangle. So if we have 12 here, we have 12 there. If we have 9 here, we have 9 here. So let's start. So missing side, I'm just going to write them in instead of doing that because, well, we will where we have to do math. How about that? So 12, 12, we filled in these sides. So if this is x's square root of 2, this is going to be x divided by the square root of 2, because remember we divide it by the square root of 2. That makes this nope, almost wrote it wrong. This is the same, okay? And we'll get a real number actually. So 12 divided by 2 square root is 8.48, so 8.5. So this is 8.5. All right, so down here, now we're dealing with this triangle. So x is 9 here, this side. So 2x, or 2 times 9, is 18. This is x, or 9 times the square root of 3, which is also equal to 3 square root equals 15.58 or 15.6. Okay, so that's that one. Yep, that's all the lengths. And see, the only time I used the calculator was to get rid of the radical, or the fraction in the radical. Just using the rules. I wrote them in red. Recommend you guys do that. I may actually give you guys this next test on paper because I really think it might work better. All right, number 14. And this finishes this topic, and this will close out the video. All right, so a roof's cross section forms a right angle. That's right here. Consider the diagram below that shows approximate measures of the cross section. Determine the values of x, y, and z. All right, so y is right here. That's the entire length of the roof. Z is right here. That's the cross section, and then x is this side of the roof. Okay, before we get started, so 45 means that this is a 45, 45, 90. So this side of the roof and z are going to be the same. Don't get it confused with that x. That's the x they want. And then this is x times the square root of 3. So whatever this is this times that times the square root of 3 will give us this number. Now if this is 30, that makes this 60. So luckily for us, this cross section z is x for both of these triangles. This side of the roof is x times the square root of 3, and this guy is 2x because that's the hypotenuse. I wrote all those in red, these in blue. Alright, so now we're going to start over here. So if our hypotenuse is 2x, or twice the length of this guy, z is 34 divided by 2, because that 34 is twice this number. Half of 34 is 17. I'm going to write that in, 17. So this over here is going to be what this was, 17 times the square root of 3. Now I need to get that real number because y is going to be whatever this is, 17 to the square root of 3, plus whatever x is over there, this guy is over there. Don't get the x's confused. Okay, now over here, if this is 17, because this is a 45, 45, 90, this is 17, this guy is 17. So we can write that in there, and we can write that in there. This x, I know, is this 17 times the square root of 3. So we're going to get x, we're going to get y at the same time. So let me pull the calculator. 17 times 3 square root equals 29.4. So 29.4 plus 17, because that's this, is 46.4. So y, the whole length of the roof, is 46.4 from here to here. And then this side is 29.4. So we got x, y, and z. We just got them back. Alright, that closes out this video. If you guys have any questions, ask me in class. Hope you have a great night. We'll talk to you next time.